Section 1.3, we're talking about factorising. Now this starts very simple with stuff that actually you've been doing since year 7 really. 3x plus 9, you bring a 3 out the front because 3 fits into 3 and 3 fits into 9 and so on, right? Now we're not going to recap this sort of thing. This is just factorising by pulling out the first, pulling out the most you can, right? Pulling out the biggest number and pulling out the biggest letter terms you can. So here we've got 3x squared minus 9xy, where you can take 3 out of 3, you can take 3 out of 9, you can take x out of x squared, you can take x out of xy, and we end up with this thing, all right? Hopefully sort of straightforward. Now, when we get onto quadratics, things get a little bit more interesting, and there's two things I'd like to focus on here. First of all, this rule here, if you haven't seen it before, is the difference of two squares rule. Very quickly, the reason it works is if you take x plus y, x minus y, and you expand the brackets out, you get x times x is x squared, x times y is minus xy, y times x is plus yx, y times minus y is minus y squared. Minus xy plus xy, so we get x squared minus y squared. So if we expand the brackets out, we get from here to here. If we start with something that looks like this, we can factorise it till it looks like this, okay? So you've seen that before at GCSE, but it was, again, one of the nasty things, one of the harder ideas that maybe didn't pop up very often. At A level, you need to be aware of it. Now, I was looking at this the other day. Here we go. So x cubed minus 25x, and the question is factorise that, okay? Now, you need to be so aware of difference of two squares at A level that I'm looking at this and I'm already thinking difference of two squares, because I've got two terms in algebra, one take away the other, and this one here's got a 25 in it, and 25 I'm seeing as a square number. So I'm looking at that and I'm sort of sniffing a difference of two squares. Now I can't do difference of two squares straight away, but if I factorise it to this, then a lot of people would stop there and say, well, I factorised it, there's nothing else I can do. But actually, look here, look, that is a difference of two squares. Now, that is how aware you've got to be at A level of difference of two squares. When you see this, you're thinking, is that a difference of two squares? So just a quick glance through the exercise, look. And I'm just looking for the ones where I've got a subtraction, two terms and a subtraction. Now, not everything with two terms and a subtraction is going to be a difference of two squares, but just glancing through this with an A-level head on, I'm noticing this one, this one, this one, this one, this one, this one. They're two terms with a subtraction in between. This one here is very like the one I've just done as an example. This one here, okay? I'm spotting these. And when you've seen enough of these questions, when you've seen enough exam paper questions where you missed it because you didn't spot the difference of two squares, you'll start thinking about that. So the advice I can give you is, whenever you're thinking about algebraic stuff, try and have some sort of notice in your head that just reminds you, difference of two squares, have you checked? Is there a difference of two squares about? Can you factorise by difference of two squares? Particularly if you see anything about factorising, or if you're trying to factorise, just double check for difference of two squares. That's one thing. I said there were two, and here's the other one. We can factorise quadratics, and here's one in the example 7, part A. This is a straightforward quadratic to factorise because the coefficient of the x squared is a 1. If the coefficient of the x squared is a 1, you just look for two numbers that times together to make the constant and add together to make this term here, okay? And hopefully you're familiar with that. I'm not going to recap, that's GCSE stuff. Two numbers that times together to make minus 6 and add together to make minus 5. Sorry, I will recap this because the example set it out a slightly different way. So if you've got a coefficient of 1, again, this is recap, feel free to fast forward until I get to the next bit if you're comfortable with what I'm doing, but I put it in a set of brackets like this. If I've got 1x squared, that must have come from x times x. Two numbers times together to make minus 6 and add together to make minus 5. So I'm looking at probably a 6 and a 1, and if it's a minus 6 and a plus 1, they'll add together to make minus 5, and they'll times together to make minus 6. So that one, not too bad. Now what happens when I end up with something where the coefficient of x squared is not a 1? Well, there are a few different methods here. The one that I favour is essentially the same as the book, and there are clever things you can do with grid patterns and all sorts of things. I'm going to explain the method that I like. So the way I do it is, remember this is A, B and C. So the 6 we call A, the B we call -11 and the C we call -10, like in the quadratic formula. So what you're going to do is you're going to do the A times the C, or the number at the front times the number at the end. Now what I'd normally do is I'd just write that over here, -60, and put it in a little circle just for me. And that's what I'd call the magic number, right? That's our magic number. And that's the one we're interested in. Two numbers that times together to make 60, but now they need to add together to make -11. So two numbers that times together to make 60, add to make -11. Now, if you can't see that, factors of 60 are going to be your friend here. So if we think about factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, where are we? 5 and 12, 6 and 10, and this is why they've chosen these numbers as an example, by the way. When there's lots of factors, it makes it difficult to factorise this without a method to follow. So this is why we're doing it this way. 7 doesn't fit into 60, 8 doesn't fit into 60, 9 doesn't fit into 60, and 10 we've already got. So there are all my factors of 60. Now if I look at these, I need a pair of them which will add together to make -11 if I get the positives and negatives right. Or 1 and 60, no good. 2 and 30, we're looking at things like 28 and 32, right? Well, that's no good. 3 and 20, no. But 4 and 15, if I get the symbols right, should work, shouldn't they? So let's have a look. 6x squared. Now, I'm going to leave the 6x squared alone. I'm going to leave the -10 alone. 4 and 15, I'm going to put that, well, if I had a -15 and a +4, then I would have -11. -15 and +4 also give me -60. So all this I do over here in rough working out, okay? And this is my neat working out over here. So +4 and -15, so I'm going to write -15x plus 4x, and by the way, it doesn't matter which order you write those two in, this will always still work, okay? So this turns into this. All I've done is I've split up that middle term in this way. Took me all this working out, took me a lot of time to do it, but now I've done that, this should be easy. Here we go. I'm going to look at the first two terms, and I'm going to factorise. I can pull a 3 out of both of them, I can pull an x out of both of them, and what I'm left with is 2x minus 5. Then I'm going to factorise the next two terms, and I should, I suppose, do that because that plus symbol is in there. So what can I pull out? I can pull a 2 out of both of these terms, plus 2x minus 5, okay? Now, this thing here, look, if you notice, this bracket and this bracket have got the same things in them. And the only way they won't have the same things in them is maybe one of them will have a factor of -1. So you might have to write this as 3x here, and you might have to put a -2 here, right? So we could factorise out a -2 here if we'd wanted to instead of a +2. So the only difficulty you'll have is if you have got the minus sign the wrong way around for the question, okay? So these two are both the same. So this thing looks like this. It looks like, well, if it was 3x times y plus 2 times y, well, what I'd do is I'd take the y out the front and I'd have 3x plus 2 left, okay? Well, that's exactly what I'm going to do, only instead of a y, I've got 2x minus 5. So 3x times this plus 2 times this, and this thing here is the same as this thing here. It's exactly the same as this, and instead of y, I've got 2x minus 5. So 2x minus 5 out the front, 2x minus 5 times 3x gives us this first term. 2x minus 5 times 2 gives me this second bit. So there is my fully factorised form, okay? Quick recap. A times C, first number times the last number. Remember that the C involves the minus sign if there is one. Write that down, that's your magic number. Factors of the magic number, because you need to find two numbers that times together to make your magic number and add together to make the coefficient of the x here. Split the x term up into two numbers, minus 15 plus 4, and why minus 15 and plus 4? Well, because they fit. Times together to make minus 60, add together to make minus 11. Once we've done that, factorise the first two terms, factorise the second two terms to get to this stage. When you've done that, this bracket here and this bracket here should be the same. Pull that out the front, and what you've got left is that bit and that bit. If those two brackets aren't exactly the same, try just factorising an extra minus sign out of one of them. Okay, so that's the factorising covered, and that is everything that's new. I'm just having a quick look at example 8 on page 8. You might want to do the same, but I don't think there is anything in there that we haven't seen. No, it's just a combination of pulling out an x and then factorising the quadratic which is left. Okay, so that's section 1.3.